Hello students, in this video session we will discuss about the IEEE standard 802.16, under which we'll focus mainly on the WiMAX technology. So this is coming under Unit 1 of Wireless Networks course 19AC 507, and the course outcome of our first unit is to write the salient features of various wireless networks. So in the previous sessions we might have discussed about IEEE 802 standard and its different types. So now let's move on to look about our WiMAX technology. So what is WiMAX? Any guess? Yes. So wireless interoperability for microwave access. So I repeat, WiMAX stands for wireless interoperability for microwave access. So this is defined under the IEEE standard 802.16. Apart from this, we also have 802.15, which is the Bluetooth technology, 802.11, which is a wireless LAN Wi-Fi. So we do have multiple hop ad hoc networks. So what is the main goal for this WiMAX technology? The main objective of WiMAX technology is to provide high-speed internet access to home and to business subscribers without wires. So hence the name wireless, right? So in fact, this WiMAX is a digital data communication system which is greatly helping us to deliver high-speed broadband services up to a distance of around 50 kilometers. And this WiMAX name, right? So this was actually created by WiMAX Forum, and the term WiMAX is derived from the phrase worldwide or wireless interoperability for microwave access. So this system is mainly used to popularize our broadband access only. So when we normally use broadband access, the way cell phones are used or the way the cell phones are replaced or the traditional telephone communication system, right? So this WiMAX is now trying to replace, or this has replaced the broadband access through landlines, DSLs, and of course the cables. This is also an alternative method to our Wi-Fi, of course. So now we'll move on to look at the working principle of WiMAX technology. Let us continue. So from this WiMAX architecture, or from this, we will be able to understand a simple function or functionality of how this WiMAX works, right? So in this picture, you will be able to locate the internet service provider or ISP. So this gets connected to the internet with the help of internet backbone network. So now the service provider must choose the appropriate geographical locations according to the area of coverage in order to set its base stations. So we'll have a base station as well as the substations. Base station is normally acting as a WiMAX transmitter here. So generally, this base station covers up to approximately 30 miles of area, and in case if the ISP wants more coverage area, we can install another base station which further adds one more 30 miles of area into our range. This depends upon the ISP's coverage requirements. We can just extend the range of communication of our WiMAX. What are all the major advantages of this WiMAX technology? The first and foremost advantage is the larger coverage area. So this offers a high-speed internet to a very long distance. And then we have a very good scalability. We will be able to set up a large number of WiMAX towers in a limited span of time. Okay, so apart from traditional wiring systems which require more planning, design, of course, heavy labor, the deployment of WiMAX or the feature of WiMAX helps us to deploy larger number of WiMAX towers within a shorter span of time. Of course, there is inbuilt QoS or quality of service in the WiMAX system. So this greatly helps us for a smooth establishment of network connection, and there is multi-user connectivity. So that is one of the important advantage of WiMAX. What is this multi-user connectivity? So this in fact says that a single WiMAX tower will be able to connect with 100 clients at the user end. So I say it in WiMAX technology offers a very good multi-user connectivity for us, right? So not only the advantage, the system of course provides certain drawbacks. So there is a limited data rate, and as the distance increases, the range of communication increases, the speed decreases. And when we go for larger coverage area, there are few interferences which may affect the system performance or the network performance. So the system has to be designed in such a way that we have minimal interference of other noises in the channel. So with this, we will summarize WiMAX. So WiMAX stands for Worldwide or Wireless Interoperability for Microwave Access, and actually comes under IEEE 802.16 standard. So under 802.16, we have 802.161, 162, 16A, 16B, 16C, and of course 16E. So 16E stands for Mobile Wireless Metropolitan Area Network, wireless MAN. And this is the general architecture of 802.16, where we have data control plane, management plane, which is mainly looking after the network management, and of course the higher MAC layers. So this greatly contributes towards service-specific convergence, as well as the security and management entity systems. So talking about the physical layer, which is the bottommost layer. So this mainly deploys directional antennas, and we implement different duplexing schemes like FDD and TDD. So frequency division duplexing or time division duplexing. So hope everybody knows the concept behind time division duplexing and frequency division duplexing. So let me not take much of its time to explain these two concepts. We'll move on to MAC, media access control. So this establishes the connection oriented. So we have a connection ID called CID, and the service continues with the help of this ID. And the channel access will be decided by the base station here. So you have MAP, which defines the upper link channel as well as the uplink data bus profiles. And we have a downlink data bus profile defined by downlink MAP. Both will be transmitted in the beginning of each downlink subframe. So this is how our TDD transmits the frames through the network. So we'll have a collision frame access burst along with the bandwidth request, and there is a signal transmission gap introduced between the frames. Talking about the different uplink periods, we introduce initial maintenance opportunities where we defined the ranging to determine the network delay and to request power or if there is any profile changes. However, there are chances for collisions to occur in this interval period. We also have request opportunities where the SS data frames request bandwidth in response to polling from the base station. And also we have data grants period. So here the SS transmit data bus in the interval granted by the base station, and also we define or we address the transition gap between the data intervals for synchronization. So how do you go for bandwidth request? So there are three different ways. Either we can use the connection request opportunities, or send a standalone MAC message called bandwidth request, or a normal piggyback, a bandwidth request message on a data packet. Yes. After requisition, we go for bandwidth allocation. So here, either we can choose grant per subscriber station, or the bandwidth is allotted based on grant per connection system. So the decision will be based on the requested bandwidth and QoS requirements.